Okay, in this video I am going to start you on worksheet 22 and 23 just to review about measurements. Remember in our exploration when we used different precision rulers to measure those lengths, we have a value which we measure, which we call the measured value, and we have a value that we are measuring, which sometimes we don't know exactly what it is, which is the real value. And here we see that the real value, when it's 1.34, depending on how precise your ruler is, you might measure that as 1.3. Okay, and then what we want to figure out is what was the error in our measurement. Okay, so the error in your measurement, there's three kinds of error, and the first one, which is the simplest, is the absolute error. If you remember, you calculated the absolute error in the exploration we did. You took the measured value and you subtracted the real value. Okay, and the way we got the real value is we just measured it with a very precise ruler and did the best we could. Okay, so in this case the real value is 1.34 and the measured value is 1.3, and the absolute error would just be the difference between those two. You just subtract one from the other, and it doesn't matter which direction you do it in, because in the end the only difference is going to be it's positive or negative. And absolute error, the reason why they call it absolute error is because it's the absolute value of the error. So if you get negative 0.04 because you happen to put a negative number, or you put the bigger number after the subtract sign, like 1.34 is bigger, you're going to end up with a negative number. That's okay. You take the absolute value. That's why I put these vertical bars here. Remember, vertical bars mean absolute value. I shouldn't draw two vertical bars because two vertical bars mean something else. So left vertical bar, right vertical bar, that means absolute value. It makes a positive 0.04, or if you're lucky and you subtract the big number minus the small number, you're already going to end up with 0.04 without taking the absolute value. But absolute value is easy, right? Okay, now we move on to relative error, and I want you to write this down in your notebooks because that way when you go back and try to remember which is which, you won't have to look through these videos or whatever. It's not something that you're not gonna have to look through this video again. You just want to like write down the definition so that if I'm not right next to you, you have it. Okay, the relative error is useful because the absolute error doesn't really tell you if that error is meaningful or not. Like sometimes, let's say you're measuring the Empire State Building and the error of your measurement is 1 meter, and then you're measuring your house and the absolute error is 1 meter. It's like the error of 1 meter for measuring your house is a lot worse than the error for measuring the Empire State Building, because the Empire State Building is huge and your house is small or medium, and 1 meter for your house is a bigger relative error than when you measure something huge. So how do we adjust the absolute error, which doesn't take into account the size of the thing you're measuring? That you use relative error. And so what you do is you just divide the error of what you just measured, 0.04 centimeters, and you're going to divide by the real length of the object, just to give perspective. Okay, so in this case we were measuring something that was 1.34 centimeters long, so we'll just take the error 0.04 and we'll divide by 1.34, and our error is 0.0299. We'll just leave three significant figures. And is there a centimeters after this? No, there's not, because look, the centimeters cancel out just like numbers do. So it's just 0.0299 with no units. If you notice in the absolute error, there are units. Okay? Now we move on to the last one, which is actually pretty easy. Whenever you change a decimal to a percentage, what's the rule you use? Well, if you have like 0.5, what's the percentage equivalent for 0.5? We know it's 50%, right? What's the percentage that's equal to 0.9? We know that's 90%. The reason, the way you can get that mathematically when you get something that's not so obvious like 0.03 is, let's see what we did. 0.5, to go from 0.5 to 50, you multiply 100, right? To go from 0.9 to 90, you multiply by 100. And if you notice, the word percent for Portuguese speakers, it has a meaning, right? Because that means per 100. So basically you're taking any decimal, multiplying it by 100 to get the percent. So 0.03 times 100 gives us 3%, right? And that's kind of tricky sometimes. When we get a lot of zeros in there, we forget, oops, there I just messed up. 0.003, change it to percentage, it'll be 0.3%, okay? So we look here, the number we have is 0.0299, and the percentage here, if you multiply that times 100, it would move the decimal 0.2 places, and you would have 2.99%, okay? So that seems like a pretty small error, okay? So that's how you figure out the three kinds of error. And now we'll go on to the worksheet, the worksheet page, okay? And I'm not gonna tell you everything here, but just to go over the highlights here. The first thing you're going to do is you're going to tell me the number of significant figures in each one of these numbers. So x has a certain number of significant figures. Let's do the first one. I'll do the first one for you. That's 2 significant figures, right? Okay, so x has 2 significant figures, and then y has how many, and z has how many, okay? And be careful with these zeros here in the front and the back. Remember, if a 0 is a placeholder, it is not a measured 0, it is just a placeholder, okay? Now, when you take your x, y, and z, so your x is, it says calculate exactly, so you're going to use the values they gave you, which is x equals 0.12, y equals 0.0316, and z equals 808. You're going to put these numbers in here on your calculator and calculate that out, and be very careful that when you have a horizontal line, that implies that the top is in parentheses and the bottom is in parentheses, okay? So when you do PEMDAS, you need to be careful that you put parentheses around the top and the bottom, just to be sure, okay? Like in this case, if you don't put it on the top, it's going to be fine because there's a multiplication on top, but on the bottom, if you don't put a parentheses, you're going to have a calculator error, which, you know, a lot of people made on the last test, so be careful with that. Okay, then when you move on, write all the values of x, y, z correct to one significant figure. What you're going to do, the first step is you're going to round. You're going to round 0.12, you're going to round 0.0316, you're going to round 808, and you're going to put them here, okay? And what you should have left after you round is you should have one significant figure. So if you remember, like for example, if you have 340 and you round it to one significant figure, you're just going to leave the first significant figure, so you're going to have 300, right? Or if you have 0.045 and you're going to round to one significant figure, you're just going to keep the first significant figure, so you're just going to have 0.05, for example, okay? So those are examples of rounding to one significant figure. That's what you're going to do here. And then you take the values that you just rounded and you're going to put them in this equation and you're going to multiply it out. Okay, and then you're going to get a slightly different number, right? Because the first number was calculated exactly, and this number is calculated using rounded to correct to one significant figure. So it's going to be different, right? So then you're going to use this exact value, and then you're going to use this more approximate value, okay? And then you're going to figure out the absolute, relative, and percentage error. And if you remember, the absolute error is just the measured minus the real, and of course you take the absolute value. The relative error is the absolute error divided by the real, and I'm just going over what we just did last page. Percentage error would be the relative error times 100, and then you just put a percent sign after it, right? Okay. Then you write all the values of x, y, and z corrected to significant figures, so a little bit more accurately, and then you're going to repeat the calculation again, and then you're also going to calculate the absolute error, relative error, percentage error here. So since in the part above we calculated using one significant figure, and here we're calculating using two significant figures, what do you think about the error? Do you think it's going to go down or up? So think about that. Okay. So if you don't get what you think it should be, then maybe go back and check what you did with your calculator. Okay, now I'm going to show you something you need for the next section. If you have a brand new calculator or you've never done trigonometry on your calculator, you might need to do this because when you get a new calculator, it comes, it comes with the trigonometry in radians mode. Okay, and so you would need to, I'm just fixing the screen here. So you would need to adjust that. Okay, let me do that real quick. Okay, you would need to adjust that to degrees mode, okay, for this next part. So I'll show you how to do that. You go to mode, and then you go to, there's radians and degrees here. It's on radians, as you can see. Oops, went out again. Go to degrees, and then you just hit enter. Okay, and now we're in degrees, and to get out of that you go second mode, second quit, right? Okay, and now when you do like the sine, you do the sine of 45 degrees, it's going to give you the right thing. Okay, it's going to think this is 45 degrees, not 45 radians. And we won't even talk about what radians are because we don't need to know that for this class. Okay, so, and that's enough for you to go on to the next page, which was 23. Okay, so let's just, I'm going to show you 23 for a second. It looks pretty much the same as the last page, except for it's got a sign in the equation or the expression. Okay, went out again. Okay, so that's enough to do page 23 also, and that's the end of this video.